Merci. So I'd like to introduce Professor Kamiyama, who is invited by Leonardo Lingua-Costa, but Leonardo is stuck somewhere. He has lots of strikes in his airplanes, and so he cannot introduce you. So I was asked to do it. So I learned that you worked in Osaka University, in NTT, and you're now with Ritsumeikan University in Japan. And I'm glad to introduce you for this talk on Anycast CDN.
Yes, nice. So thank you for your introduction. And thank you very much for inviting me to this seminar. So my name is Noriaki Kamiyama from Ritsumeikan University, Japan. So before starting the presentation, I briefly introduce myself and the Ritsumeikan University. Okay, so here I show my brief history. So after getting a PhD at Graduate School of Osaka University in 1996, I joined the University of Southern California for 1 year as a visiting scholar. Yeah. And then I joined the NTT. That is a Japanese biggest telecom company like France Telecom. And I have worked in NTT lab for about 20 years. Then I moved to the Fukuoka University. Yeah, so that is also a private university located in Kyushu area. Kyushu is west south part of Japan. Yeah. Then after 4 years, I moved to the Ritsumeikan University, Japan. And my research field is basically computer networks, and especially including the content delivery system, traffic measurement and control, and network design and network security. Here I show the brief introduction of the Ritsumeikan University. Yeah. So Ritsumeikan University is one of the largest private university in Japan. And I think it's ranked the third ranked private university in Japan. So the toppest is Waseda University and Keio University. Then third one is Ritsumeikan University. And Waseda and Keio located in Tokyo. But Ritsumeikan University located in Osaka, Kyoto, and Shiga Prefecture. So we have 3 campuses. And actually, recently, our department have moved from Shiga to Osaka campus. So now my lab and my department locate in Osaka, so close to the central Osaka area. So it's very, good location for convenient to go to many good places, including Kyoto, Osaka, Nara. So especially these 3 cities are very popular for foreign tourists, actually. And a lot of international conference has been held in this area. So perhaps some of them have also been to this area. Yeah. And okay, so let's start the today's talk. And here I show the graph. Although this is a little bit old, but it shows the ratio of traffic volume caused by consumer internet video and CDN traffic. So using the CDN content delivery network, we can effectively or efficiently deliver digital contents to users by using CAS servers. And more than 30% traffic or 50% traffic is delivered CDN in 2015 and 2020. So now I think the ratio is over 80%. So CDN is widely used and popular technique in the internet to efficiently deliver content. Here I show the overview of the CDN. The CDN providers such as Akamai or Cloudflare provide a lot of CAS servers in various networks. Then, when user makes a content request, DNS server will select one of the CAS servers, which is estimated to close to the requesting user. Then, user terminal request contents to the selected CAS server instead of origin server. As a result, the network distance to data source to the user terminal is dramatically reduced. So we can save the network consumption as well as we can reduce the latency to users. Here I show the major CDN services. So there are a lot of CDN providers in the world. And the top one is CDN services with the largest share of the HTML file. So the top ranked one is Cloudflare. So Cloudflare is most popular now. Then Google Cloud CDN, Amazon Cloud Front, then Fastly. And these are the other ranking of the largest CDN services. And we can also see that almost Cloudflare and Amazon and Google Cloud occupies a large part of CDN market. So here I show briefly summarize the Cloudflare. That is a CDN provider established in USA in 2009. And the advantage of Cloudflare is its low cost. So this CDN service is popular in small companies, not only large companies, but also small companies. And content providers can manage its own. Cloudflare, although this is a CDN provider, it also manages its own global network. So they can provide access point with less than 50 million second access for 95% population in the world. So thanks to operating its own global network, they can use the information about network topology and network status, including the congestion. So they can more efficiently select the CAS servers. And the advantage is also the security enhancement. It protects CDN against the DDoS attack and also provide WAF. So here I show the classification of CAS server CS selection method. So we can classify the selection method into two types. One is DNS-based CDN. The other is the Anycast-based CDN. So for CDN providers, how to select CAS servers is an important issue because the performance of CDN strongly depending on the selection of CAS servers. And the first approach, that is DNS-based CDN, it provides the CDN providers different IP addresses to each CAS server CS. So when user makes a request, it normally uses a DNS system to resolve the IP address of sending server. So in this case, user DNS query is forwarded to the DNS server operated by CDN provider. Then DNS server of CDN provider selects the best CS and responses its IP address to requesting user. In Anycast-based CDN, on the other hand, it provides identical IP address to multiple cache servers. So the issue is how to select the cache server which assign the identical IP address. To solve this issue, Anycast CDN best uses the mechanism of Anycast IP routing. So this is one of the basic functions provided by IP networks. And as a result of autonomous route selection of ASes, CS is selected. I more explain about Anycast-based CDN in next slides. Anyway, a traditional CDN such as Akamai uses the first approach, DNN-based CDN. On the other hand, new CDN such as Cloudflare, Anycast-based CDN is used for CS selection. And in this study, we also focus on the Anycast-based CDN. Here I show the IP Anycast. So it provides the identical IP address to multiple hosts. So normally in the internet, each host connected to the internet is assigned unique IP address. However, in the IP Anycast, the same identical IP address is provided or assigned to multiple hosts. And gateway routers forward packet to anyone of candidate. So let's see an example. Here, this table is a forwarding table of ASA. DA is a destination address, and NH is a next hop. So in this case, the packet with destination address of X, both ASB and ASC are candidate to forward packet. So in this case, ASA can send packet with DA of X to ASB or ASC. Both are possible. However, in IP Anycast, one of candidates is selected. For example, in this case, SC is selected. So packet is forwarded from SA to SC, then arrive to host X of this host X. Actually, in this case, there are two host X here and here. And these two hosts have the same contents. However, in this case, I show the example in which SC is selected by by IP Anycast. So CS selection using a network layer function of the internet. So this is a very big characteristic of the IP Anycast. Here I show the Anycast CDN. So Anycast CDN uses the mechanism of IP Anycast. So in this case, assign the same IP address to multiple cache servers. And route and CS selection depend on BGP Anycast routing mechanism. So packets are not always forwarded to most appropriate cache server. So it totally depends on the routing policy of BGP among multiple ASes. So CDN providers cannot control the Anycast routing mechanism. So it totally depends on the network service providers. So here I show this table from this paper. So this is 2017. And this table summarizes that for each of the 5 Anycast CDN, so this number indicates the number of CAS servers included in Anycast delivery group. So it shows that optimum fit means the best CAS server is selected. The probability that the best CAS server is selected. On the other hand, misfit means the best CAS server is not selected by Anycast CDN. So this table indicates that as the number of CAS server increase, especially L is consists of 144 CAS servers, but the optimum hit ratio is decreased to 24%. So this means that accuracy of CS selection is degraded as CS count in Anycast group increases. So this is because that CDN providers cannot control the Anycast IP routing. So as a result, the optimality of CAS server selection will be degraded when the number of CAS servers increases. And here I summarize the purpose of this work. So the idea is that we should reduce the CS count constructing each Anycast group. Because if we decrease the number of CAS servers in one Anycast CDN, we can expect to improve the probability of optimally selecting CAS servers. So we should limit CAS servers at areas with high popularity in CS set. Because content popularity has a geographical locality. So popular content depend on the location. Not identical content is popular in all areas. So the popular content is different depending on the locations. So we should provide CS set for each content depending on the geographical pattern of demand. But in the current Anycast CDN, just single Anycast group without considering the geographical pattern of demand is provided. So we want to provide multiple CAS server set depending on the geographical locality and try to reduce the number of CAS servers in each CDN group. So the goal is we propose the method of constructing CAS server groups of Anycast CDN, considering geographical locality of content demand. And here I show the approach of this work. We try to cover areas of high demand by few CS sets so that we can reduce the size of forwarding tables at routers. And we propose a generic algorithm constructing the best CS set. So here I show the idea of constructing a limited small CS set. So we call link as the CS set. So for example, for some contents, link R1 is used. So contents which is used link R1, only test servers constructing R1 is selected. So we provide multiple links. I mean the cast server set for multiple contents. So we want to reduce the cost and lookup time of router forwarding tables. So we want to limit the number of links. Of course, as the number of links increases, we can more effectively accommodate many contents, but we also want to limit the number of links. And we want to also cover a large part of demand by few CSes in each link. So construct each link by just CSes in high demand. So to increase the probability of optimally selecting cast server, we want to reduce the number of cast servers in each link. And at the same time, we also want to cover many demands by just using a small number of cast servers. So we should select limited number of cast servers from just locations with expecting the large demand. Here I show a greedy-based algorithm. So, okay, yeah. So before showing the GA-based algorithm for comparison, I here show the greedy-based algorithm, so more naive approach. So basic method generating links based on greedy algorithm. Here, N is the number of links, and K is the number of cast servers in each link. And generate link in descending order of propriety. So for each content, we try to make each link, but in the descending order of popularity. So because popular contents will expect it to get more requests. So we want to cover large demand for popular contents by appropriately setting a link with a high priority. So for most popular content at first, we extract the top 5 ASes with the largest demand ratio. So because it's very difficult to consider the all cities with traffic demand, so we just limit the top 5 ASes with the large traffic demand, and randomly extract K minus 5 ASes because total number of CSes in each link is K. So, and repeat these two steps until generating N links without complete overlaps. And so, okay, so up to N contents, we have already produced all required links. So for the remaining links, we also need to construct links, but we cannot add more links because we have already reached the number of links N. So we need to use existing links for contents with low popularity. Okay, and yeah, so this is a greedy-based algorithm. And here I show another more sophisticated approach using the generic algorithm. So GA is a computational method efficiently solving combinatorial optimization problem, and it mimics the natural evolutionary processes in inheritance, selection, crossover, and mutation to search for wide solutions. And using this GA, we also propose a method of optimally constructing the cassava set. So we define each gene of GA as the one set of n links. Because each gene includes all information about the solutions. So this consists of the locations of K-cast servers of all the n links. Because the number of links n and the number of cast servers in each link are fixed or given values. So each gene needs to contain the total information about the cast server locations. And we randomly generate the initial set of genes. Then at each step, at each repetition, the adaptation degree of each gene is the average ratio of demand of the top 5 ASes covered by the set of all contents. So because we want to maximize the total cover ratio obtained by produce limited number of links. So we want to keep genes with high cover ratio. So we use the average ratio of demand of top 5 ASes, which is defined as the cover ratio as a selection criteria of gene. And we repeat these processes or generations for some times. Then the final set, in the final set, we select the best gene with the largest cover ratio. Then after generating links, we also need to assign each content to one of the generated n links. So here I show how to assign each content to each generated link. So we select link Rm used for delivering each content M. Then first assigns link with a maximum cover ratio of content M to link Rm. So this is a very straightforward idea. Then when no links cover demand of content M, in this case, we need to find the geographical distance to from the high demand city to the one of the closest cast server in existing links. We try to calculate the geographical total distance D between the top 5 ASes in demand for each content and all ASes in the constructing links. So we can expect to reduce the delay by allocating link with a minimum D to link Rm. So next, I show the numerical evaluation of the cover ratio. So evaluation criterion is the demand coverage ratio. That is a degree of agreement between ASes in being assigned to each content and top 5 countries in demand. And evaluation condition is that as a content, we use the most popular 100, about 100 web pages in which the top 5 ASes covered 90% or more demand based on the similar web. And for ASes, we selected 300 ASes with the largest cone size. Then for GA, we set the number of G to 300 and number of generation is just 10. Here I show the average cover ratio against N, the number of links generated. And for some value of K, K is the number of CAS servers in each link. And the left figure plots the result obtained by the first approach is a greedy algorithm. Then the right figure shows the result obtained by generic algorithm. And we observe that as N increased, the cover ratio also increased because we can accommodate more contents in more with links with larger cover ratio. So the average cover ratio also increased, but the size of forwarding table also increased as N increased. And comparing these graphs, we found that the cover ratio of generic algorithm was larger than that of the simple greedy algorithm. So we confirmed that the effectiveness of using the GA compared with the greedy method. And for example, when N was greater than or equal to 10, we obtain the 0.8 or greater average cover ratio. So by just limiting the number of links to just 10, we can expect 80% or more cover ratio. So here I show the cumulative distribution of cover ratio. So left figure shows the result of N of 10, and right figure shows the result of N of 20. And so basically, as K increased, the cover ratio also increased. So by now, I show the result of only cover ratio, but the more important issue is how much we can reduce the delay by limiting the number of CAS servers in each link. So we evaluate the effect of multi-link Anycast CDN on the latency reduction using the actually measured round-trip time, RTT. And we measure the RTTs for optimum and suboptimal CS selections and calculate the average delivery latency per content with given success ratio of CS selection P. Because the actual success ratio of CS selection depends on the CDN configuration as well as Anycast routing. So it's very difficult to exactly or accurately set this P. So we provide or get the value of P, and for each given P, we evaluate the expected average delay reduction. And we use the Live Atlas Internet measurement platform to measure a delay between various pair of nodes. And measure RTT from proofs in content demand country to ASes with CSes. Okay, so we need to define the optimum and sub-optimum CS selection. Yes.
So P is the probability of
Yes.
getting the content in the cache when the request is sent.
Yeah, no.
P is something different.
P is a success ratio of CS selection. So if P is 100%, all CS selection is perfect. So all time, best CS is selected. This is P equals 100%. And if P is 0%, no request will be provided from not optimal cache server.
Yeah.
Yeah.
But the fact is that why is it so important to get the optimal server? Maybe a second best server is good enough. Even if I don't get the best server, I don't care as long as the delay remains.
Yeah, right. Yeah.
So
This is a very good question, I think. Yeah. So actually, it's not the best cache server selection is not required. Yeah, you are right. So to accurately evaluate the average delay reduction, we need to use some CDN platform such as Cloudflare and to establish experimental CDN platform using the Cloudflare. Then we try to measure the actual Anycast CDN server selections on the experimental platform. Then we maybe calculate the delay reduction. So now, my students will try to do that. But in the currently, this result, we, simplify the assumption and just give the probability of success selection as P. Yeah. So by changing P, we can see the influence of P on the delay reduction. Yeah, thank you. And we define the CS selection with the smallest RTT in country as optimum CS. So for each country, multiple cache server are provided. And of course, over countries, we can select cache servers using Anycast CDN. But if we define the suboptimal CS as per countries, it's not so good result. So we just limit the cache server selection in cache servers in each country. So optimum and suboptimal cache server selection are based on the same country. And here I show the definition of average delay. So OMI is RTT from ICE country with largest demand for content M to optimum AS. And whereas SMI is that of suboptimal AS. So we can make the average, weighted average of OMI and SMI by this equation. So OMI, P is a suboptimal selection probability. So P times SMI plus 1 minus P times OMI. Yeah. Yeah, I show the evaluation conditions. So, okay, so we consider the three scenarios. So about N and K. So in the method, we assumed N of 20. So 20 rings are constructed. And for the value of k, the number of the servers in each link, we considered three cases, 5, 10, and 15. And comparison method is existing method, just using a single large link, like the current Microsoft CDN. So here I show the average RTT. So x-axis is the P, so selection probability of suboptimal CS. So as P increased, of course, the average RTT also increased. Yeah, because of the suboptimal CS selection. But in the case of existing method, I mean just using the single link. In this case, average RTT sharply increased as P increased. On the other hand, in the case of proposed GM method, the increase of average RTT was more smooth. So around when P was about 0.3, that is a cross point. So if P was larger than about 0.3, the proposed GA-based method was superior to the existing single link because we can obtain the small average RTT. And according to this paper that is published in 2015, about 55% of users were routed to optimal CSes. So about 45% users are routed to not optimal CSes. So based on these assumptions, we conclude that the GA-based CS link construction method is superior to existing single CS set. So now I conclude this presentation. So in Anycast CDN, which is widely used in the current internet, the degrade accuracy of CS selection is an issue as CS count increased. And also increase the router cost as the link CS set count also increased. So we should effectively construct links consisting of limited CSes based on geographical locality of content popularity. So we propose a link construction method considering geographical locality of user demand. And we confirm that we achieve the 0.8 or greater coverage ratio with just 10 links. And when probability P of suboptimum CF selection exceeded around 0.3, the proposed method using GA was effective. Okay, thank you. That's the end of the presentation.
You have time for a few questions. So what if the demand is not sustained? Like it evolves over time, etc. How long does it take to reconfigure everything?
Okay, so thank you for your questions. So we assume the static user traffic demand in this evaluation. So actually, traffic demand will vary or change as time elapsed. So we should also consider the dynamic traffic demand pattern. But in this study, we assume the just static traffic demand and use the I think let me see. I think, we set the demand ratio of each contents using the zip distribution. Because I think similar web page just provides the rank of contents based on the popularity, but does not provide the exact ratio of demand in this web page. So I think we assume the zip distribution for user contents demand distribution.
If I understand correctly, you select the best route based on BGP data, like smallest response time or something like that. But how often is BGP data updated? Because everybody goes to the server, but the TTL will go up.
Yeah. So thank you for your questions. That is a very good point. So BGP routing is not static, so it's frequently changed. So another issue of IP Anycast CDN is its fluctuation of server selections. So during the contest delivery session, perhaps cast server selection will be changed because of the dynamics of BGP route. But in the current evaluation, we do not exactly consider the BGP route in the evaluation because we have just simply giving P, as I explained before. So in current future examinations, we try to construct a test bed on the Cloudflare like CDN, more customized CDN service. Using the more customized CDN service, we try to construct a test bed and try to evaluate the dynamics of BGP routing as well. Thank you.
I have a question perhaps. So when you get these figures on RTTs or even the chance to make it. So, do you use the real geographical data or do you use a model? It seems to be very dependent on the, as you say, the geography on the, how do you get these figures on the performance evaluation and the effect of the on the performance of the various parameters? How is this built?
Okay, thank you for your questions. Actually, okay, so I think okay, so similar web page also provides content popularity ranking for each country. So we can find the top 5 countries with the largest demand for each content. So we just use this popularity ranking in each country as a demand data. So we can select the top 5 countries for each content. So this is a geographically dependent demand data.
Thank you.
Maybe you told that at the beginning, but what is the advantage? It's a general question. What is the advantage of Anycast CDN versus DNS CDN? Because also in the conclusion, it seems that Anycast just adds additional problems because the CDN provider doesn't have control. But I don't see the advantages. And then the second connected question is, if instead of having one ring, you have multiple, then you need a selection of the appropriate ring. And how would you do it? Would you do it with DNS, with DNS redirection? Because in that case, you would need a system that has both the complexity of the DNS based and the issues of Anycast based CDNs.
Okay, thank you for your questions. So DNS-based CDN, DNS-based CDN also has an issue. One of the issue is that it's normally difficult to estimate which CAS server is most closest to requesting user because it's based on the IP address of local DNS server. So CDN providers DNS server need to select CAS server based on the IP address of local DNS server. So sometimes, the mapping between IP address and actual location is not correct. So sometimes, based on this not correct data, some not ideal CAS server will be selected by the CDN, DNS-based CDN. So I think, many, new CDN try to use Anycast-based CDN. And for the second question, I think, we can also consider the combining these two approaches. So using the multiple Anycast CDN links, so we can also select one link based on the DNS-based CDN. So because each link has different unique IP address, so we can select one of the links by the CDN, by the DNS mechanism. So we can combine also these schemes.
But you get, and then you get both the disadvantages of DNS and Anycast-based mechanisms. So in the end, I don't know if you gain something or not, but it would be interesting.
Okay. So I think, if we, each content, I think, it's one demand or popularity, geographical locality. So depend on the geographical locality of content's popularity, we can construct each link or a set of contents. So I think, this assignment are more static, so not dynamically changed. So I think, we can statically assign links for contents. So in this case, we can just use Anycast-based CDN, but provide a IP address or assigned IP address to each content in advance.
Thank you. Any other question, comment? Okay, thanks, speaker.
That's very